Assalamu alaikum wa rahmatullah, grade 11 students. Today we will talk about elastic and inelastic collision. Our objective today are to differentiate the different types of collisions. We have elastic collisions where objects after collision still separated, or inelastic collisions where objects become one object. Then we have to find the final velocity of objects and perfect inelastic collisions and perfect elastic collisions. So, what are elastic and elastic collisions? How can we differentiate between them? If the kinetic energy of objects before collision equal the kinetic energy of objects after collision, this means we are talking about elastic collision or perfectly elastic collisions. But if the kinetic energy is not conserved, so it's an inelastic collision, as you can see in the concept map in front of you. Now, what about elastic collisions? How can we describe the collision as elastic collision? If the objects collide and return to their original shape, this means they had elastic collision. Now, also, if the kinetic energy remains the same after the collision, it is again an elastic collision. Now, perfectly elastic collisions satisfy both conservation laws shown below. If you take a look at these two laws, first law here is the conservation of momentum. It's m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. As you can see here, m1 stands for the mass of object 1, m2 stands for the mass of object 2. Now, initial and final means before collision and after collision, and v stands for the velocities. For the second law, it's the kinetic energy conservation law. It applies only for perfectly elastic collisions. Now let's take a look at this example about elastic collisions. Now we have two cars. Each one has mass of 1 kilogram. One is at rest, which is car B, and one is moving with velocity 1 meter per second. After collision, both cars shows what you see here, that car 1 stops from moving and car 2 starts moving with velocity f1 meter per second. If we calculate the kinetic energy before collision, as you can see in front of you here, and the kinetic energy after the collision, we will have the same value, 0.5 joules. Once the kinetic energy before collision and kinetic energy after the collision are the same, this means we have perfectly elastic collision. Now let's start with another example about elastic collisions. Look at the figure in front of you here. You will see two billiard balls. Sure, they have the same mass. If the red one, which is ball A, has a velocity of 4 meters per second, moving towards the yellow ball, which has velocity of 0, it's at rest. Now, which of the following possible final velocities satisfies the law of conservation of momentum? Let's take a look at these three possibilities. How we will deal with such a thing. As both poles have the same mass, we need to find the momentum before collision and momentum after collision. So, because they have the same mass, it's just adding up the speeds and multiply it by m. So the initial momentum will be 4 plus 0, which is 4m. M stands for the mass of one of the billiard balls. So if one of these three gives final momentum to be 4m, this means it gives the answer. So what do you think? Which one is the answer? 2 plus 2 gives us 4m. 0 plus 4 gives us again 4m, which is the mass. 1.5 plus 2.5, again it's 4m. So the answer will be all three. Now here we'll continue with the same example with the two air balls having the same velocities. Sure, they have the same mass. But here we are concentrating about applying the law of conservation of kinetic energy. Now, which of these three options satisfies the law of conservation of kinetic energy? Applying the law of conservation of energy in this example shows that the only valid answer is the second one. Please try to do it by yourself, all of you students. Now, this slide and the slide before illustrates that conservation of momentum can happen in many ways, but conservation of momentum and kinetic energy at the same time happens only in one way. Now we will start talking about perfectly inelastic collisions, which is another special case of collisions. How do I know it's a perfectly inelastic collision? When two objects collide and stick together, this means it's a perfectly inelastic collision. Like when you are playing football or when a meteoroid is striking the Earth. In this case, the momentum is conserved, but the kinetic energy is not conserved. And this is a big difference between perfectly inelastic collision and perfectly elastic collision. Now, in this case, masses will combine and form one object moving with a final velocity, as you can see in the following equation. Now let's talk about this example about perfectly inelastic collision. If we calculate the total momentum before the collision for the two cars and the total momentum of the two cars after collision, we will find them equal, which means that the law of conservation of momentum applies in this case. But if we calculate the total kinetic energy of the two cars before the collision, which will we find to be 0.5 joules, and then calculate the total kinetic energy of the two cars after collision, which you'll find to be 0.25 joules. This shows that the kinetic energy is not conserved. So the law of conservation of kinetic energy cannot be applied in this case. Now let's continue with perfectly inelastic collisions and take this practical example. A 2 times 10 to the power 5 kilogram train car moving east at 21 meters per second collides with 4 times 10 to the power 5 kilogram fully loaded train car initially at rest. The two cars stick together. Find the velocity of the two cars after the collision. First of all, we have to write the given. We have first object, which is the moving train car. So M1 equals 2 times 10 to the power 5 kilogram. And V1 initial is 21 meters per second. And the second object, which is a fully loaded train, its mass, which is M2, equals to 4 times 10 to the power 5 kilogram, and its initial velocity, V2 initial, is 0. Now we have a statement tells us that the two masses should be sum up because it says the two cars stick together. So the final mass will be the mass of object 1 and object 2. So M final will be 6 times 10 to the power 5 kilograms. Then we have to decide which equation we need to use to find the final velocity. Because they said the two cars stick together, we need to use the perfectly inelastic collision equation, which states that m1 v1 initial plus m2 v2 initial equal m1 plus m2 times v final. By substituting with the given, we will get this, and we have to solve it for v final, which gives us the final answer to be 7 meters per second to the east. Don't forget that the velocity has direction because it's a vector quantity. Now, if I ask you to find the total initial kinetic energy and the total final kinetic energy and decide if the kinetic energy is conserved or if the collision is elastic or inelastic. After doing calculations, you will find that the total kinetic energy before collision was 4.4 times 10 to the power 7 joules, and the kinetic energy after the collision is 1.5 times 10 to the power 7 joules. This means the kinetic energy was reduced. So this is inelastic collision. This is an inelastic collision. Now we will brief what we learned about inelastic collisions. Kinetic energy is less after collision. What happens to the lost kinetic energy? It is converted into another forms of energy, something like increase in temperature as internal energy or sound. So some kinetic energy may remain after the collision, or it may all be lost. Also, energy can be as reforming shape of the object, as you can see in the picture in front of you. In this collision, which is inelastic collision, it's perfectly inelastic collision, all kinetic energy was lost as heat and in reforming the shape of the object and as sound. Now we will summarize what we learned in this video. We have three types of collisions: perfectly inelastic, elastic, and inelastic collisions. In perfectly inelastic collision, the objects after collision stick together so that their final velocities are the same, and the only conserved quantity in this case is only the momentum. While in elastic collision, the two objects bounce after the collision so that they move separately, and the conserved quantity or quantities are the momentum and the kinetic energy. While in elastic collision, take care of this. It's not perfectly inelastic. It's an inelastic collision. The two objects deform during the collision so that the total kinetic energy decreases, but the objects move separately after the collision. And the only conserved quantity in this case is momentum. Now, thank you all. And please go to study guide and solve problems in pages 14 and 17 to 17, and then do the assignment on Edmodo. I hope you stay safe and fine. Thank you.